So let's solve this problem. What we have in our problem? An automobile travels on a straight road for 50 kilometers with such speed. It then continues in the same direction for another 50 kilometers at another speed. Okay, so what we have? We have movement between 2 points. It's a straight road, so it's a movement by a straight line. Wow, okay, this is a straight line. Movement between points A and B. But the whole distance, as we can see, 50 and 50, 100 kilometers between 2 points. But we separately consider first half of the trip and the second half of the trip. Why? We consider them separately because the speed on every segment is different. So because of that, we consider these these parts of the row separately. Let's write what we have. We have displacement S1, displacement vector quantity. It's equals 50 kilometers. 50 kilometers. And another segment of the road is displacement S2. It's also 50 kilometers actually. They're equal. What is the difference between them? How they distinguished from each other? The point is that during this first displacement, on the first segment of the road, our automobile has speed 40 kilometers per hour. So speed V1 equals 40 kilometers per hour. And during the second half of the trip, during the next 50 kilometers, our automobile had speed V second 70 kilometers per hour. Okay. So what they ask us? They ask us to find what? What is the average velocity of the car during the whole trip, 100 kilometer trip? Assume that it moves in the positive x direction. So it's a positive direction, okay. Okay, so they ask us to find average velocity. Velocity is a quantum, is a vector quantity. Average velocity they ask us to find. Okay, and they ask us what is the average speed? Second question. Okay, average speed also we need to find. So they ask us to find average velocity and speed. Let's look what is the difference between velocity and speed. Velocity, as we said, it's a vector quantity. Speed is scalar. What is the difference? In our case, it's actually not much difference, but let's suppose that our automobile moves from point A to point B not by this straight road, but it moves by this road, by this trajectory, like this, like this, like this, like this. So, and we need to find velocity, average velocity during this trip from point A to point B. So velocity with the arrow average would be the displacement of our automobile What is displacement? It's the shortest distance between these 2 points. So, it moved by this rod. The displacement is this distance, 100 kilometers. So this displacement is 100 kilometers divided by time consumed for this trip. And now let's find average speed. Average speed. To find average speed, we consider the length of all this road, all this track, all this trajectory. So let's say it's the length of all this trajectory, all this move, yeah? Divided by the time consumed. Time obviously the same. So we can see that when we are finding average velocity, here we put the displacement, the shortest distance between points. But when we are finding average speed, we put here in the numerator, we put all these lengths of all the road made by our automobile. So correspondingly, the average speed would be in this case much longer. But for our problem, it's actually not that important because our automobile moves by straight road. Yeah? So when we find average velocity and average speed, it's the same number, but the difference only that average velocity is a vector quantity, and this number of average velocity should have a sign, so positive or negative. But we have here assume that it moves in the positive x direction, so it will be with the sign positive plus. And average speed won't have any sign because speed is it's not vector quantity, it's a scalar quantity, it has no direction, it has only number. Okay, first let's find average velocity. Let's find, so it's, as we said before here, it's displacement from A to B divided by time consumed. Simple, nice and easy. We know the displacement, it's 100 kilometers. But we don't know the whole time consumed for during whole trip. But we have speed. We have speed during first part of the road and we have speed during second part of the road. Can we find, let's say, average speed using this speed during the certain period of movement? No. If we try to do this, we do it wrong. We can't find average speed based on a speed during certain segments of the road. Maybe during the movement it stopped somewhere or something else. To find average speed, we should consider only the whole distance between points and the whole time to find average speed or average velocity. In our case, it's the number, as we said before, the same just because automobile moves by a straight line. Because of that, we can a little bit substitute the words average speed and average velocity because numbers would be the same. If the automobile moves by the roundabout road, we can't use these terms interchangeably because the numbers will be different. The speed will be bigger because it was made bigger trip, bigger length of the trajectory of movement. Okay, so this displacement we know, and we can't find average speed using these speeds during the certain period of movement. We can use this speed only to find these two things which we need to find average speed. The distance, the whole distance we already know, and time. We don't know time yet. Let's find. The whole time consumed during the trip, it's time during the first period of movement on the first displacement plus time during second displacement. Let's find time for first displacement. It's displacement itself divided by what? By speed of the displacement, v1. So displacement 50 kilometers divided by speed during this period, it's 40. So it's 5 divided by 4, it's 1.25 hour. So for first displacement, our automobile it was made this displacement in 1.25 hour. Let's find time consumed for 4-second part of the road. It's S2 divided by speed 2 equals again S2, it's 50 kilometers divided by, during the second segment of trip, speed was 70. Okay, so it's 5 divided by 7. Where is my calculator? 5 divided by 7 equals 0.7 hour. So 1.25 plus 0.7, it's 1.95. 1.95 hour, almost 2 hours. Almost, but not exactly. The whole displacement we know it's 100 kilometers. It's 100 kilometers between points A and B, divided by the whole time consumed, 1.95 equals, where is my calculator? 100 divided by 1.95 equals 51.3. 51.3 kilometers per hour. This is our velocity. We found our average velocity. Velocity vector quantity. So it has sign, and we assume that it moves in the positive x direction. So it has sign plus. And average speed, it doesn't have any sign, it just 51.3 kilometers per hour. As we said, the number of average velocity and average speed is the same because our automobile moves on a straight road, yeah? So just by the shortest way. If it moved by the way around, the numbers would be different and the average speed would be higher because the length of the road would be higher. Velocity would be the same. Would be less because velocity consider the distance only the shortest displacement between points. Such things.